Question 3. The angle of depression of the base of the tree from the top of the building is 65 degrees. The height of the building is 30 meters. How far away is the base of the tree from the building, correct to 1 decimal place? I'm going to turn this worded problem into an abstract trigonometry problem in order to solve it. The first thing we're told is that the angle of depression of the base of the tree from the top of the building is 65 degrees. This is the point from the top of the building. This is the angle of depression. So that's the angle looking down from a horizontal reference line. So that's the red dashed line here. Note that this horizontal reference line is parallel with the ground. Also note that the building is assumed to be 90 degrees with the ground, hence forming a right angle triangle. Now the question is asking for the distance between the base of the building and the tree. Now in order to find that distance, we need another angle inside the right angle triangle in order to apply trigonometry. Now we know the height of the building, which is 30 meters. We know the angle of depression, which is 65 degrees. So we need another angle inside the right angle triangle in order to apply trigonometry. So if this is the angle of depression here, and this line is parallel with this line, these two angles are alternate, hence equal. So the angle of depression and the angle of elevation are equal to each other because they're alternate angles on parallel lines. So if that's 65 degrees here, this angle here is also 65 degrees. Now in this right angle triangle, the building represents the opposite side, and the distance between the base of the building and the tree represents the adjacent side. So the tan ratio will need to be applied to find the value of x, which represents this distance here. So we can form an equation. Tan of 65 degrees is equal to opposite over adjacent, so that's 30 over x. Notice that the variable is in the denominator. So to make that the subject, we can place the 30 on top of tan 65, so 30 becomes the numerator, and tan 65 degrees becomes the denominator. So x is equal to 30 over tan 65 degrees, which evaluates to 13.989 and so on, which rounds to 14.0 meters, correct to 1 decimal place. Therefore, the answer is option B.